Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this example we're going to look at multiple linear regression. In the previous example we had a single exploratory variable of income, so this was known as simple or bivariate linear regression. Multiple linear regression is a very similar approach. The only difference is we're going to have more than one explanatory variable. So for example, we may have the loyalty index. We may also have the recent or new spend of that customer. So what we want to do is to take the combination of income, loyalty, and new spend, build a model with those that will allow us to ultimately define or predict what the lifetime spend will be, which is what we can see here on the left on the response axis. That's our dependent variable. So that's multiple linear regression. So now we're in HANA Studio. Now if you haven't already seen the video on linear regression and the introductory video to regression, I do recommend that you do so because there are important concepts covered there that I'm not going to go into any detail in this video itself. So we can look at our input data set. We see we have the ID for each customer, we have the lifetime spend and income that we already saw in the simple regression, but we also have new spend, recent spend, and loyalty for each customer. So what we're going to do this time is try to use the Power Library to help us predict lifetime spend based on the new spend, income, and loyalty all combined. So it's basically using multiple explanatory variables. So we need to write some code as always, and here's our first example of the code. It's almost identical to what we saw with the regular simple linear regression. We have the same types of tables. The only real difference is that we're specifying here not one but three different independent or explanatory variables. Previously we just had one. One other difference that we're making is that we are going to have a different value for variable num in our parameter table, because this is where we specify how many independent variables there should be. And in our case now we have 3. Previously it was 1, so we need to set that value to 3. Otherwise this is basically the same code that we were already running for the simple regression. Very little changed. So let's run the code. Like we did previously, it's the LR regression, so linear regression. So let's run this to create the procedure. So we've run the wrapper generator. Then we can create our view for our input data with the 4 columns in the right order. We can create the other tables and an output view, and we can update the parameter table. So now we've done that, and now we can go and actually create our model. So let's quickly run that, and it runs in just a few seconds. And as previously, we're going to get a number of different outputs. So for example, we've got the coefficient values. So for this new model, we can see it's slightly different. We've actually got 3 different values to follow on the initial one, and that's because we have 3 explanatory variables. So in fact we have a coefficient that reflects each one of those 3, which effectively will multiply as part of the equation. But of course we don't have to do that ourselves, because HANA is going to do that for us when we want to actually predict some values. What we can also see is the significance table, and we can see our R² value, 0.859, so fairly close to 1, so looking good, and the F value of 297. Now this is slightly different in terms of our calculation from previously. So if we go just back to the distribution calculator to look at that, we have 150 rows of data, but this time we have 3 explanatory variables. So we should do 150 minus 3, 147, and then minus 1, which is our constant. So we would have 146 in this case. And to get a very significant statistical result here, we would use the 99th percentile. So let's hit calculate. And now we can see the F value is 6.81. So that's certainly well below the 297 that we see here. So we can say that this is a very significant model that we've created. And what I can also show you this time is just to have a quick look at the PMML model that the PAL created for us. In fact, it's just a column in the table. We can see here, this is the PML, the the software vendor independent way of representing a predictive model. And we can see we've got information about the different fields in there, what kind of data are they. We can see what we have in terms of the target, or in this case it's the dependent, which are the independent variables. We can see the R-squared value, we can see the individual coefficients. So we see all of those bits of information that we'll put in tables. We'll also get those in a PMML format as well, which we can then save and use in any other software should we want to do that. So now we've created our model, what we want to do next is to actually predict some new values using it. And again, this is pretty much exactly the same as simple linear regression. We're going to simply have an additional number of variables. So when we input data, we're going to input 3 explanatory variables along with an ID, which will give us the output, the predicted value of lifetime spend. Again, we use the forecast with linear regression. In fact, for single and multiple or bivariate and multivariate linear regression, you use the same algorithm inside the PAL library. It's just a question of how many exploratory variables that you specify. So we use the wrapper generator to create that. We can create a view so we can look at the results. And importantly here, this is where we import the source data, so the new IDs and the value for income, loyalty, and new spend. And what we'll then hopefully see at the end is the output spend, the lifetime spend. So we run that, it's all run very, very quickly. And if we go to our views and just refresh, we can see our predicted value. Let's open that. And what we can see here, we've got values that we already had for the 150 original parts of the data set, but now added on at the end, we can see we have the lifetime spend of 4.8 and 9.8. These are the 2 values calculated by the PAL library based on our model, based on the input of income, loyalty, and new spend that we provided to it. So that's the result of our prediction.